This lesson is about simplifying rational expressions. Keep in mind the definition. A rational expression is simply a fraction, in which the numerator and denominator are polynomials, such as this rational expression. You have a polynomial in the numerator and a polynomial in the denominator. This is also a rational expression. It has simply already been factored. In order to simplify a rational expression, you must completely factor the numerator and denominator and then cancel any terms that appear in both the numerator and denominator. For instance, this is not factored, so we cannot simplify this expression. This is not factored. However, these are factored, and since there's an x plus 5 in the top and the bottom, I can cancel them and simplify the expression to become x minus 3 over x minus 7. That is a simplified rational expression. First, consider an example with regular numerical fraction, such as 270 over 360. If you completely factor both numbers, 270 is 2 times 3 times 3 times 5, and 360 is 2 times 2 times 2 times 3 times 3 times 5, you can go through and cancel any terms that are in common. There we go. And I'm left with 3 over 2 squared, which is 3/4. Next, consider an example of polynomials. My numerator, x squared plus 2x minus 15, can be factored as x minus 3 times x minus 5. My denominator, x squared minus 2x minus 35, can be factored as x plus 5x minus 7. You see the x plus 5 is in both the numerator and denominator, so you can cancel them, leaving behind the x minus 3, x minus 7. Here's another example. Simplify the following rational expression. Remember, rational just means ratio, which means fraction. So the numerator, x squared minus 7x minus 18, can be factored as x minus 9 times x plus 2. The denominator, x squared minus 4x minus 45, can be factored as x plus 5 times x minus 9. Since both the top and the bottom have an x minus 9, I can cancel them, leaving behind the x plus 2 over x minus 5. This expression is simplified. Here's another example, much larger. We have two polynomials that are cubics, and we're going to factor them by grouping. So first, use factoring by grouping and difference of squares to completely factor the numerator and denominator. Notice that the numerator you factor by grouping into x minus 5 times x squared minus 9. The x squared minus 9 is a difference of squares, which can be further broken down into x minus 3, x plus 3. So the entire numerator is 3 factors. The numerator you can also factor by grouping, and the result also has a difference of squares, so the x squared minus 25 you can further factor into x minus 5, x plus 5, giving you 3 factors as well. So rewriting the entire expression with your 3 factors on top, the 3 factors on bottom, you can cancel anything that they have in common. There's an x minus 3 here and here, and there's also an x minus 5 here and here, leaving behind x plus 3 times x divided by x plus 5. Here are some practice problems. Give it a shot, hit pause, and then when you're ready, you can look at the answer key on the next screen. Have fun!